lecture number 13. Exercise question number 2.4. Please open your textbook and read it very carefully. Sentences is not written here, so please take care of this. Here, what is given? Given is 68% nitric acid solution. 68% nitric acid solution is there. That means 68 gram HNO3 which is dissolved in 100 gram of water. That is nothing but 68% nitric acid. So first we have to find out, remember here you have to find out moles. Moles of nitric acid, that is solutes. So N2 is equal to W2 divided by N2. So what is W2? W2 is 68 gram which is given at here, and N2 is nothing but molecular mass of nitric acid. If you calculate from this, hydrogen is 1 atomic mass, nitrogen is weak acid at 14 and oxygen is 16. So according to that, molecular mass or molar mass is 63. So 1.079 moles obtained. Now remember, density is equal to what? Density is nothing but grams per ml. That means it is given 1.504 grams per 1 ml. That means 1 ml is equal to 1.504 gram. So 1.504 gram equals 1 ml. So what about 100 ml? Therefore 100 grams equals what? And therefore 1 into 100 divided by 1.504. So obtained value is 66.49 or say 49 ml. And this ml is converted into liter because you have to find out molarity. So here 66.49 into 10 raised to minus 3 liter. So molarity is equal to what? How many number of moles which is dissolved in what is the volume, and that is nothing but liter. So mole is 1.079 which is given in we obtain this value 1.079 mole divided by 66.49 into 10 raised to minus 3. If you calculate, then you obtain 16.23 molar, 16.23 molar, and that is the correct answer. So according to this we calculate. Now question number 2.6 is very important, which is a volumetric analysis or say acid-base titration in presence of mixture of two bases Na2CO3 and NaHCO3. So here you see, in amount in mixture of Na2CO3 and NaHCO3 is not given, but it is given equimolar is there. So first of all, if we consider equimolar at a time in a mixture Na2CO3 and NaHCO3 is, in from that we considered x gram. So what is another 1 minus x gram is there, and therefore we can say that molar mass of Na2CO3 if we calculate 106 grams per mole. Molar mass of NaCO3 is 84 grams per mole. Please calculate it because whatever the atomic mass is there, it is given to you, and from that you have to find out molar mass. So number of moles of Na2CO3 is equal to mass of Na2CO3 divided by molar mass of Na2CO3. So x divided by 106 mole, and that is equation number 1. Number of moles of NaCO3 is equal to mass of NaCO3 divided by molar mass of NaCO3 is equal to 1 minus x divided by 84 mole. But in your sentences or say in a question it is given equimolar. Equimolar means what? Number of moles of Na2CO3 is equal to number of moles of NaHCO3. So but at equimolar, N Na2CO3 is equal to N NaHCO3. So therefore x divided by 106 is equal to 1 minus x divided by 84. If you calculate, you got x is equal to 0.5579 moles. If this value put at here instead of x, if we write 0.5579 here by 106, then number of moles of Na2CO3 is obtained. So 0.0053 mole, and number of NaCO3 is also obtained. 1 minus 0.5579 divided by 84. So here you have to remember one equation. 2 moles of HCl plus Na2CO3 gives twice NaCl plus H2O plus CO2. This is equation number 1. Here 1 mole of HCl is reacts with 1 mole of NaCO3. It produces NaCl plus H2O plus CO2. Here 2 moles of HCl is required. Here 1 mole is required. So you have to find out we can say that For Na2CO3 we find out how many mole of HCl is used. So 1 mole of Na2CO3 is equal to 2 mole of HCl. Therefore 0.0053 mole of Na2CO3 equals what? So here 0.0053 into 2. Therefore 0.0106 mole of HCl. Similarly for NaCO3 we have to find out moles. Total moles of HCl we have to find out. For that, first you understand that 1 mole of Na2CO3 is equal to 1 mole of HCl. Therefore 0.0053 moles of Na2CO3 equals what? So here multiplication takes place and you got 0.0053 mole of HCl. So total mole of HCl is 0.0106 plus 0.0053 which is given here. Total mole of HCl, total mole of HCl is equal to 0.0106 plus 0.0053. So you obtain 0.0159 moles in 0.1 molar HCl which is given. So 0.1 molar molarity is given and therefore we can say that 0.1 mole HCl contain 1000 ml. Therefore 0.0159 mole contain what? So if you calculate it, you got 159 ml solution of the HCl which is we have to use. Okay, so this example is very important. It is nothing but on the basis of acid base titration. Make a screenshot. Okay, now very important formula for chapter number 2 solutions. Just you have to remember it and write down this formula for 10 times and remember it. Okay, so first is percentage W by W is equal to mass of the component in the solution divided by total mass of the solution into 100, and that is nothing but percentage W by W. Percentage V by V is equal to volume of the component in the solution divided by total volume of solution into 100. Third number is very important, ppm. Number of moles of the component divided by total number of moles of all the component into 10 raised to 6. Million means what? You have to remember 10 lakhs and therefore 10 raised to 6 is there. Fourth one is very important, chi1 plus chi2 is equal to 1. Therefore chi1 is equal to n1 divided by n1 plus n2, chi2 is equal to n2 divided by n1 plus n2. Once again remember, 1 stands for solute and 2 stands for solvent and 2 stand for solute. Remember it, do not cross it. 2 stand for solute and 1 stand for solvent. Okay. Number of moles of component, this is very important. In each and every example, this type of formula to remember. Mass of component divided by molar mass of component. Mass of component given in grams or whatever it may be unit, you have to convert in terms of grams. So grams divided by grams per mole. So you got mole. N is equal to W by M. Remember this. 6.1 molarity, capital M. 1000 into W2 divided by M2 into given volume of solution in ml. This one you know very well. Small m, that is molarity. 1000 into W2 divided by M2 into W1. W1 is given grams of solvent. Here 1000 is there. That's why it comes of grams. Seventh one. This P is equal to KH into chi. This is a Henry's law. Eighth one, P total is equal to P1 plus P2 is equal to chi1 P10 plus chi2 P20, and therefore P total is equal to, remember this formula, if you put P10 then you put plus sign, here P10 is there, in bracket write down P20 minus, once again write down P10, here 1 is there, bracket complete, chi2, okay, is equal to P20 plus P10 minus P20 chi1, bracket just you see. Ninth one is P1 is equal to chi1 into P10. This is a non-volatile solute and this is considered for volatile solute. Remember, just you draw attention towards theory and according to that you prepare this formula. 10th one, relative lowering vapor pressure of solvent P10 minus P1 divided by P10 is equal to N2 divided by N1 plus N2. For very dilute solution, N2 is a, we can say that, take neglected. So here N2 divided by N1. So W2 divided by N2 into M1 divided by W1. This is nothing but chi2 and that is nothing but mole fraction of solute. 11th is elevation in boiling point. Delta TB is equal to KB into M. But suppose if it is multiplied in I, Just you see, note is given. If equation 10 to 13 multiplied by I, then it is for ionic compound. Those are dissociate in terms of ions, or those are associate in terms of molecule. For that, we can say that equation 10 to 13, or say whatever the formula is there, 10 to 13 is used. So delta TB is equal to Kb into M. Delta TF is depression in freezing point is equal to Kf into M. 13 example of formula is there. Pi V is equal to W2 divided by N2 RT. This is nothing but according to PV is equal to NRT. N is equal to W by M. If you put, then this formula is very easy. 14th is a very easy, you know, the dissociation association. I is equal to normal molar mass divided by abnormal molar mass is equal to observed colligative property divided by calculated colligative property. 15. I is equal to total number of particles after dissociation. D stand for dissociation or A stand for association, and divided by total number of particles before dissociation or association. Please write down this formula for 10 times and you remember it. If you do not remember, then this example is not just calculated by you. So in exercise, whatever the important examples are there, they are calculated at here. But you make a practice of this. Make a screenshot. Thank you very much.